Thank you for coming to my talk. I'm Gan. I'm a postdoc here. So I think this is my first time actually to give a presentation at HitLab after I arrived on April. So it'd be better to start with a short brief overview of my background. So I was doing my undergraduate study in Gyeongbok National University in Korea and went to post-tech to do my graduate studies. I was under supervision of Professor Gerard Jung Kim. And before I came here, I was working as a researcher at A3, which is a research institute run by Korean government. And I was actually a visiting student here about 8 years ago, so it's second time here at that. So, and my research interest is to talk in broadly, it's all over the HCI, human-computer interaction, especially on 3D and multimodal user interfaces, including 3D displays and user tracking and sort of things. And to narrow it a little bit down, virtual, augmented, and mixed reality, those terms coming up mixed up through my research topics, and especially I was focusing on authoring tools for my PhD thesis. So I would be talking about that today. And I was working on developing some virtual reality-based training systems while I was in A3. And it's on my research interest list, but I haven't done that much work on that area, but I'm still working on computer-supported collaboration, and might be one of the topics I would like to do while I'm in HitLab. And currently I'm working on Android outdoor AR library, including the WYSIWYG AR application and the AR game project, making some noise. Sorry about that. And I'm also in charge of managing the vision space. There's nothing much research going on the vision space at the moment, but we are planning to start some kind of research to add natural gesture interfaces connected to the vision space environment. So hopefully we'll start working on that. So why did I got interested in authoring? So thinking of virtual reality or augmented reality as a interface for next generation media. Talking about the media, the key is a content, what kind of content we are delivering to the end users. So, and if we talk about content, it's much more dependent on what kind of tools we are using for generating contents or making contents. And depending on that tool, you can imagine that how far that artists or directors who are not really computer science, who doesn't really have computer science background or engineering background, could contribute to developing different kinds of contents, and so that make that medium very rich with full of different kinds of contents. So thinking of that kind of authoring environment, when we see the authoring tools on multimedia side, especially on 2D multimedias, we have all different types of authoring tools, ranging from low-level programming tools to higher-level authoring tools like Flash or Director, and many of those are even used by novice users. But if we look into virtual reality or AR authoring tools, there is nothing much there. And it is still hard for novice users or artists to create AR contents, because most of those tools are programming libraries and not really supports kind of intuitive interfaces. And of course, there are some desktop-based AR or VR authoring tools, like just the Build AR we have at our lab, and or the Alice, which was developed by Randy Posh's group, which is pretty intuitive and pretty nice. for novice users, but they are still limited with some features that is not accessible through the authoring tool, but require some kind of programming. So thinking of that and thinking of still those authoring tools needs to be, while the contents are authored, developed on the desktop interface, they still need to deploy to a immersive environment and test there. And then if they find something wrong, they have to go back to the desktop interface and correct it, and then it goes forth. So the very initial idea was, what about authoring the virtual reality or augmented reality content within that same environment that's going to be executed? And of course, there's nothing new done. Every time, if you look into virtual reality research, there has been a lot of researches that try to construct virtual reality environment within the virtual reality environment, especially modeling geometries of the virtual environment. There are a lot of works has been done since the very early ages of it. But unfortunately, or fortunately for me, there has been nothing much that has been done for describing behaviors within virtual environment. So to describe those things, still many of the developers or authors have to rely on programming languages. And there have been a couple of works on trying to do that kind of work, but those were, the first one, the lingua graphica, which was done by Stiles in 1992, was just coining a concept of using some kind of metaphorical free virtual objects to describe a computer programming language. But unfortunately, it was just a concept and it wasn't really developed. And later on, Steven Slater's group has also worked on trying to manipulate or describe the data flow between the virtual objects and the tracking sensors, but still it was limited to describing simple connection between sensors and virtual objects. So we've decided to focus on describing layers within the virtual environment. As the research went on, a couple of other works also came along, sharing a similar concept with ours. So one of my friends at Postec developed a kind of VR kernel or shell that was using Python language to interactively describe the virtual reality scene. So we were calling that concurrent editing of virtual environment. And also the other work, which was done by Home, was proposing to have 2 users for virtual environment and 1 user for reviewing the virtual environment that has been built, and at the same time the other user on the desktop interface that could modify the virtual environment so that they could collaborate with each other to see how the virtual environment could be modified or built while it was running and being evaluated. So we thought it was quite doable, so we came up with a term named Immersive Authoring, just simply putting those 2 words, immersive, which usually is an identical term for virtual environments. And the basic theme was to make the development environment or authoring environment same with the execution environment of that content. So we came up with a couple of design principles we would like to meet. The very first one was named after WYSIWYG in 2D graphical user interfaces. I named it WYXIWYG, which is what you experience is what you get. And so we wanted to focus on that the developers could experience what was happening in with the content, real content they are developing in the very early time or early stage of development. And the other thing was, since we are using immersive environments or 3D interfaces, we wanted to use direct interaction or direct manipulations as much as possible through the authoring work. And also, since there are two interfaces coexisting inside the same environment, one would be the interface that the end user could be using, and the other interfaces could be the interfaces for the authoring. So we wanted to keep those two different interfaces consistent as possible so that there might not cause any mental gaps between switching those interfaces. So we started with analyzing what kind of tasks we have to do when we author contents. So we made a big 3 category of authoring tasks, constructing the scene and reviewing the built content and making it safe to a file system or reloading them. And mostly the other, reviewing them or saving or reloading them has kind of obvious interfaces, obvious choice of interfaces, but thinking of the content construction, which is the main core task for authoring, we wanted to design the interfaces for these. And we came up with 3 approaches to do this. So the very first one, virtual desktop interface approach, which is very simple and straightforward method that we could, if we could add some kind of desktop interface inside the virtual environment itself, maybe we could program on that virtual desktop interface to modify the virtual world. So that was a very simple and straightforward method, but the downside is that virtual reality environments are not really friendly with text informations, and also this is just reusing those 2D interfaces inside the virtual environment, so it might not take any advantages of 3D interfaces we already have in virtual environment. So the next approach was to have metaphorical objects, much more like visual language in traditional AI side. So we looked into 3D visual languages, and we thought it might be usable to describe logics behind the virtual environment using these visual languages as well. But still, since visual languages are not that common, and also 3D visual languages are usually not that easy to learn, and since it was using metaphorical objects, it was not really taking advantage of 3D interaction, but was focusing on much more conceptual things. The last approach we came up with was programming by demonstration, which is one of the research fields in artificial intelligence. And this kind of theme was focusing on how to describe programs by demonstrating what the program should act like. So for instance, this tool named Pavlov on the left lower side is a tool that you can put some 2D user elements there, and you can record your interaction with that user elements, like dragging this car to one direction, and if you record that motion, it will make some kind of rule that could be applied to this user element. And if you drag some of these bars out and then demonstrate another action that should respond to that bar changes, then the authoring tool itself will record those stimulus and response as a rule for the 2D user interface being developed. And also, another interesting work was named KidSim, which was a tool for developing simulation by kids. So this was relying on a kind of rule-based animations, which describes the before state and the after state of that behavior. So, for instance, there could be a character here which has a obstacle in front of him, and you can describe a rule that in the before stage, if there is an obstacle on the right side of this character, then at the after state you can put that character on the right side. So so these rules were generated by directly demonstrating on each user UI element. So we thought this might be quite helpful if we are describing spatial behaviors of virtual objects. So we tried to map those three approaches to which kind of authoring test it might be best. So this is a kind of structure we were thinking of. So there should be sitting a kind of content model of that virtual content, and the tool itself would include both the execution module, which will be running that content, and alongside there should be an authoring module that also talks to the execution module and generates contents out of it. Then so developing an immersive authoring tool, from that point of view, it could be done in a couple of stages. The very first stage would be, of course, identifying the interfaces what we are going to use, and also, of course, we have to define what kind of content model we are going to use, and then we can build our interface design around that virtual world or content model, so that we could use 3D interfaces to fill up those content model by generating different kinds of. So we built two types of authoring tools. One was for immersive virtual environment, and the other was for tangible augmented reality contents. And one was the one that was for immersive virtual environment was using programming by demonstration approach mainly, and for the AR authoring tool we were trying to explore the possibilities of metaphorical virtual objects. So I'll just give you a short introduction of the AR tool first. So we were targeting to develop a kind of AR storybook with this authoring tool, which we already well know with the Magic Books work. So we were targeting for a authoring tool that could build that kind of contents with it. So we started to analyze what kind of content model we would need, and obviously if you think of a tangible augmented reality content, there are physical objects and there is a virtual object which is matched to the physical objects, and in the behind there is some kind of logic going on the other side, so that it could show virtual object according to the user interaction with the physical object. So we came up with these three types of components: virtual object, physical object, and functional objects. And we tried to do a data flow model that making links between different types of components to describe different types of behaviors of that content. So these are the properties and of each component described, and of course the link is between modify the components and make a link between properties of the component. So we designed a couple of tangible AR tools that might be useful for authoring. So we had a tool called Virtual Object Browser, where we could choose 3D models from it. It was a kind of a booklet design, so that we could have different pages with different types of objects. The first page had 3D models, the other page had 3D sounds, and another page had logic boxes, and to manipulate them in 3D space, we used a cube box here, which is pretty common in tangible AR applications. So we were using that as a 3D pointer to pick up a virtual object and place it on the 3D scene and also manipulate them. And of course, to delete them, we had a kind of trash can on the backside of that virtual object browser book so that user could drop that virtual object. And we had another tool which was called Inspector Pad, which was for browsing different types of properties of objects, and then we used these interfaces to make link between properties of those components. So I think I should. So still not working with projector. So this is the object browser tool that you can browse through different types of 3D models you have on the disk. And we didn't want it to make this booklet very filled with 100 pages, so we used the occlusion-based interaction to browse between different types of 3D models. So with here, you can pick up 3D models and put it onto a 3D, AR markers, so that it could stay there. So obviously, composing a 3D scene, just placing those 3D models is very easy to do compared to using mouse to manipulate those 3D models and place it somewhere in the 3D space. So it was quite handy for arranging, placing 3D objects inside the AR scene. But much more fun part is to do describe links or behaviors between 3D objects. So you can grab another model to another marker. I'll play it a little bit faster. So then you can actually put also some sounds if you want. Oh, I'm not sure if the sound is working. All right. So you can grab those objects representing the sound to the scene, and it will play the sound when the marker is showing. So and as you can see here, the bounding box just disappear as soon as the authoring tools are out of the view, so that it could instantly switch between the authoring environment and the reviewing environment or the execution environment. So you can also put them away if you don't like, and from here we can see that modifying the properties of each object. So you can browse through the properties with this inspector pad, and of course you can have some kind of keypad that could link to the properties and change those values like that. And also we use the same interface to link, make a link between different types of components properties. So we had some virtual objects that represented logics or behaviors, like Boolean logics or kind of simple animation that rotated the virtual object, or kind of recording of motion. So you can put that logic box near to a virtual object, and you can link those properties between those so that you could describe simple behaviors. So again, the same interface to browse the object property, and you can browse into the orientation of that virtual fish and use the same another inspector pad to grab a property value from that virtual motor object, and then you can browse through the property which is showing the current orientation of that motor and make a link between them so that the virtual object could show rotating animation, you see. And also you could also link with other components like the marker so that it could, the object could stop showing when it's not there. So this is just changing the rotating speed. I'll speed up a little bit to and you can also make a little bit more interesting behaviors like linking the switch of the motor to the visibility of this marker on the right side so that the motor would stop rotating when you hide that marker. So you can hide that and stop it. So these are the basic concepts we were having, and of course we have some tools for saving and reloading the scene if the authoring is done. And this part is the same virtual object browser. At the other page we had loader function for pre-authored contents. So it's the same content. And the end, and then still describing behaviors or animations with links is very tedious. So we came up with another kind of logic box which could describe or capture the motion. So we made a kind of recorder interface that you could record the motion while the user is manipulating the 3D object. So you could do some live demonstration of how the turtle would act. Go back. And then replay it. And of course you can link the animation with some kind of visibility of other markers so that it could trigger the animation to start. So, and also we had a tool to investigate it in the immersive view, to switch into immersive view, which is a feature of Magic Book. So we were just using a simple pedal to navigate through the virtual scene if they want. So those are the simple overview of the tool. So we are using those three interactions or tangible use cases to create, destroy, or modify those properties of each component. And we later came out with a little bit more complicated behaviors like recording the motion and also using multiple manipulators to synchronize between motions. And of course, everything is on the live, so you don't really have to modify the scene and save it and reload it from the viewer, but it's all going concurrently. So to see how much this tool could be useful for developing AR, AR contents, we tried to do some user studies. So we first built a couple of scenes and how long it took. So how long it took. For instance, this contents using some motor behavior box and a couple of virtual objects, 3 minutes, and a simple game that switches the 3D model when two markers are near enough. Also took about for making each pair of those cards. And another test contents we built was a story of rabbit and turtle, the race of rabbit and turtle, and there was some kind of interaction described to select whether to sleep there or not, so that depending on the selection by the user, the end results will come out differently. So we did some, we did a formal user study as well. So we wanted to try to see if really, if this immersive authoring tool really helps in terms of developing 3D contents. So to do some user study, but it wasn't that really easy because to compare it fairly, we had to compare it with another authoring tool. But if we are comparing to totally different authoring tool, then it might not be that fair because it might have different types of content model. So we've decided to use the script. The script language itself we were using internally for the authoring tool. And before this formal user study, we tried it to, we compared it to another authoring tool which was using 2D GUI interfaces as well, but the result was quite similar with this one. So I'll just mention about this study only. So we were comparing that authoring tool with script editing, and both had same virtual world model, obviously, so it was quite fair enough to compare. And of course, we had to avoid bias from background knowledge. If you were using another authoring tool, then it might cause those who have background knowledge of that authoring tool to have advantage. So the participant had to learn both of them and experiment. So the task was to author a scene, a couple of scenes according to the specification given. So we tried to ask participants to author 6 different scenes, with 3 of them including only spatial text like placing virtual objects inside the scene, and another 3 was non-spatial text like linking properties of each component. And in overall, 12 participants tried all of those combinations. So it's within subject design. So the whole experiment took about 2.5 hours. So and the first half was for training them to help them learn both of the tools so that they could use it during the experiment. And of course, since this was kind of a very long experiment, there were some intermissions between the trials and, of course, the experiment. So this is the experimental environment. It was quite similar for both of the tools. The only difference was the immersive authoring case had a head-mounted display, and the tangible AR authoring tools together. And on the desktop interface side, we had a conventional desktop with a camera setup. So the user were provided by the user guide document during the experiment as well, since they might, especially for the desktop case, they might happen to look up the grammars of the scripting. And also the specification of the scene they are building was given so that they could look up those specifications and try to author the kind of things. So the spatial configurations were described in relative form, so it wasn't really telling the participant to place a specific virtual object at specific coordinate like 0, 10, 0 or something like that, but rather asking the participant to place virtual objects relative to each other so that to make a kind of a scene. And for the behavior specification, we didn't want it to make participants to worry about how to describe that kind of behavior. So we gave very low-level description of the behavior, just to asking them to connect this property to another. So again, 12 are participating in the study, and comparing, I mean, as a result, we came up with quite positive result. The whole task was, the overall task completion time turned out to be, took lesser in the immersive authoring environment, and especially for the spatial tasks, it was almost like half the authoring time. And for the non-spatial tasks, it took a little bit longer because it wasn't really easy to make links, describe links between virtual objects, but still it was quite marginal, the testing environment. And we also tried to see if there was advantage with the background knowledge. Half of the participants were from the VR class, who had more background on programming or editing scripts. So it turned out that background knowledge had interaction, caused interaction, making them a little bit advantage when they were using scripting interfaces. But still, even though they took advantage of their background knowledge, it didn't help much to overcome the immersive authoring. And we also collected some ratings from questionnaires, and unfortunately, it didn't turn out there was significant difference between two in terms of how easy was it to learn or how easy was it to use. But still, on the other side, we could tell that those two authoring tools were quite similar. I mean, similar enough in terms of those easiness, so that was pretty fair comparison between two. But while the rating results didn't turn out significant, but the other observations gave some insights of the authoring tool. Immersive authoring could be useful. Like we counted how many times the user tried to look up the document while they were performing their test. For the immersive authoring tool, none of the participants had trouble with the interface, so they didn't need to look up the document. But on the scripting side, obviously, since they had to memorize the syntax, they still had to look up the document. And during the debriefing session, most of the participants mentioned that the immersive authoring tool is useful for placing objects, like describing the spatial feature of content. And as a downside, they mentioned about if they were asked to place objects, a lot of objects randomly inside the scene, then that could be kind of tedious job. And on the other side, for the scripting interface, they mentioned that it could be, it could have strengths when they have to put specific values for the contents, or dealing with non-spatial features of the content. And for the downside, they mentioned about they had to learn about the grammar and to memorize it. And also they mentioned that repeated trial and error, like editing the script, reloading the scene, and then looking if it's right or wrong, and then getting back to editing. So finally, we asked which authoring tool would you use if you have to build something. Then they all turn out with they would like to use both. So since those two interfaces had kind of pros and cons, they mentioned that spatial tests would be very interesting to do with immersive authoring tools, but fine-tuning or non-spatial tests could be done on the desktop interface. So this study revealed we had to do some mixed match between different interfaces in terms of authoring, but still it showed a kind of insight that the immersive authoring tool could. So we had another immersive authoring tool which was built for immersive virtual environment. It was actually built before the AR version, but I think it is much more giving insights to how authoring tools could be look like. I would like to mention it later. So in this case, we were using a kind of rule-based behavior, much more like the Turing by demonstration approaches in artificial intelligence. So we defined a simple behavior that consists of action, context, and event. In terms of action, we are mentioning a series of functions that modify the virtual object. The context, for context, we had two types of context, which is spatial context that describes relative configuration of virtual objects, and the logical context for checking what kind of values of those virtual objects has their property. And of course, we had an event that triggers this behavior, like triggered by timer or collision, or some property. If some property change, then it could trigger the behavior. So, for example, if you're describing a behavior of a virtual fish, we could describe it simple action to move forward every time. And if you would like to describe some kind of event that when the fish is collided with the user hand to turn in different directions. So this is, and we could also describe a little bit more complex behaviors, like giving a region of interest where the virtual object should look for, and manipulate those virtual objects in that region of interest. So we're using head-mounted display and a data glove that measures the hand gesture, and we were using hand gestures, three simple hand gestures for with rock, scissors, paper gestures, which is paper is the neutral state, and if you grab something, it's the rock state, and if you point at something, pointing was used for navigating around the virtual environment. And we also, for authoring, we had to add another user interface, which is a 1D hierarchical menu system for describing different behavior. So, shoot a video again. So this is a simple example that describes a behavior to fish to turn around when it's collided by the user hand. So you can actually demonstrate it's being collided and move into the next phase of describing the behavior, and then you could record the motion of the fish by actually manipulating it, and then the system will record those steps into a rule that whenever the fish is collided with the hand, it will turn to different directions. So so that was a simple example. We could so was also able to do some little bit more
Now, we are going to make a slightly more...
Other kinds of behaviors like eating of food in front of it, so we could describe a region of interest in front of the fish, where to look out for a food, and then destroy it whenever the food comes up in front of it. So we can draw a region of interest and place a food object. It's not really visible here, but we can place that virtual food inside that region. So demonstrating that and moving into the next stage, which is describing the action, we can demonstrate to destroy that food, and you can save that behavior. And if you come to, if you play again that environment, this is just creating another food in front of it so that it's for testing. So you could have that food in front of it, and as soon as the fish moves towards that food, you could destroy it. So this is another. So using this program and demonstration approach, it seems it could be much more easier or much more effective if you need to describe spatial behaviors or spatial interaction of virtual objects. So one of my thought is to expand that research into the AR authoring tool so that we could describe some rule-based behavior of virtual objects inside the AR scene with using this kind of programming by demonstration approach. And one of the possible extension I would like to look into is to develop a authoring tool that supports collaborative authoring, so that multiple persons could gather together and make a virtual content, or even a remote person collaborating with each other. And obviously, saying about the content, it's pretty obvious that we need a kind of standard that could describe the content or the user interface. Looking into, if you look at the web, since it's based on the standard, the authoring tools or browsers or sort of things are based on the same standard, so that they could interoperate with each other, and that makes that media or medium very actively used. So I was also interested in contributing to standardization activities. So currently I'm participating some of the acts at the Web3D consortium, which is trying to develop a standard for X3D, which is a XML version of VRML. And recently there was some interesting things coming up with the HTML5, which introduced WebGL, which allows you to do 3D graphics programming inside the web. I mean, inside the web browser without requiring any kind of plugin or something like that. And on the X3D side, the Web3D consortium is trying to put that X3D, or so to say VRML, to directly embed it into the HTML, so that users could describe 3D scene within the HTML without needing to program with WebGL actually. So that seems to be quite interesting if you could have an authoring tool that could export to those standards, and that would be very useful to distribute the results of authoring tools. So that was all of my talk that I prepared today. Any questions? Yep.
So thank you for the talk. It's a very interesting topic. For me in particular, some of the work you've done is really interesting. Who is your target user for this in terms of authoring things for the? Is it really web users, or are you looking for people for video games, or because I see a lot of deep and rich content development in video games is done using standard tools that are obviously desktop based and not immersive. The experiences are, I would say, are very immersive in terms of. It seems like a hybrid approach is going to have to be used for maybe making some gross definitions for how things should be, look, move, but that to actually fine tune them, you're going to have to use more standard approaches.
So
programming approaches.
Yeah, of course. So as it was mentioned, as a result of the user study, I don't think that immersive authoring should be used for every cases of authoring, but it should be first of all, for the target user, we were thinking of novice users so that they could not program or do some programming thing, but much more like tended to use just simple tools to author 3D content. So that was the target user we were thinking of. And in terms of, obviously, immersive authoring couldn't be solution for every authoring task. So there is some of the authoring tasks that should be done on desktop and much more efficiently done on desktop. So it might, as I've mentioned at the end of the user study results, it might be good to have both of them mixed up so that the users could do some of the programming tests. That's quite similar to 2D multimedia development tools, I guess. Like Flash, they have very nice 2D UI for describing simple Flash contents, but at the back end they have some kind of scripting tool to support much more complex behavior, something like that. So might use both of them maybe.
Question one. You might mention that general standardization is occurring more on the web. I can see how you mentioned that for future research it could be worth trying to see if that's a good infrastructure to build upon. Do you think that could happen also for instance, things like the vision space where it lacks standardization, and we could take advantage of this standardization occurring in the web, or should it be done separately?
If we are mentioning about the X3D or VRML standardization, they have kind of profiles in that standard. So they have different subsets of their functions that support different types of interfaces, so to call. So they have some kind of features they only support for desktop or inside the web browser, and they have some more extensions or extended features for supporting immersive environments as well. But still, if you have looked at the VRML file, there are a lot of features inside there, but most of the features that are used these days is just those describing the geometry of the 3D scene. So there is also sensor nodes or some kind of nodes that describes the animations or something like that, but it isn't really adapted to the market at the moment. But obviously, at some point, this kind of immersive contents or AR contents would need some kind of common base or standard so that you could exchange the contents and distribute it. So actually, it could be one of the possibilities, and of course, there are other standardization organizations that they are trying to do different stuffs with AR standards, I guess. So.
It's ongoing, but it could be.
Yeah, it could be.
Right. Thank you very much, Sten.